Building the Future, Green Building in the New Millennium, brought to you by Sustainable Homes of the Future. Our natural world is in crisis. Buildings emit 40% of carbon globally. We need solutions now. Join the conversation today. Welcome back to Building the Future, Sustainability Nerds, myself included. This is the one and only podcast series where Ginger Matthews and I spread the good word about all the innovative ideas you may not have heard of when it comes to the future of building design and construction. We are committed to shifting the tide in the development industry toward greener, healthier, and more efficient buildings using sustainable systems and technologies. And speaking of shifting tides, we are here in Santa Monica, California. And you know I can't resist a pun. So today's episode is all about water, where it comes from, what it's used for, and the many ways that we can manage it more efficiently. And if we're really pushing the envelope, we might even be able to use it to power other building systems using a process called thermal recovery. Mind blown. But more about that later. First, welcome, Ginger. Thank you for joining us. And can you start us out by explaining a little bit about why water conservation is so important?
Certainly, Ian. Happy to be back with our listeners. All important water episode. One of my faves, actually. So let's start out with some statistics. Did you know that despite being 80% water, only 2.5% is actually fresh water?
I did not. That sounds like not enough for 8 billion people.
No, that's true. And even less of that fresh water is what we call potable water, water that is deemed safe to drink and cook with. So the real number is closer to 1% of potable water on the planet. So due to our changing climate, freshwater reserves are not what they used to be. So for drier climates like here in Santa Monica, California, that means more local state regulations requiring efficient use of water in all buildings, residential and commercial, and that cities are catching up around the globe. So it's going to even get tighter.
Yeah, slowly but surely. But it's necessary to account for this in any building design, to account for water use. And we talked last episode about landscape architecture and the importance of choosing plants and materials for our outdoor environment that keep that water use to a minimum and keep excess runoff to a minimum as well. We're going to be talking today about a few other basic water saving strategies that apply indoor and outdoors, like low flow fixtures, drip irrigation systems, and we'll also lay out the basics of how to design a gray water system that can help reduce potable water use by close to 50%, or in some cases over 50%. Really fun.
Yes, we'll do a deep dive on the gray water systems in a later episode. Right now, we'll just go through the basics, so stay tuned. We'll also go over some ways to automate and track water usage for your home and building. So you can track leaks and develop other strategies for minimizing water waste overall. So lots to talk about. So Ian, are there any good resources or websites out there for people to learn more about current best practices when it comes to water conservation?
That is a great way to start out. Yes. I recommend the EPA's WaterSense website. That's epa.gov, which is a great website on its own. Then throw a /WaterSense, SENSE. And it's a great resource for a deeper dive into some of the things we'll be touching on today, but also really cool to go on there and look at the partners list. You can see which companies, manufacturers are partnering with WaterSense to provide better options for consumers when it comes to fixtures, when it comes to materials, all kinds of cool stuff. Contractors are on there as well. They also have case studies and cost analyses that anybody can look at that show that on-site reuse, and that's the switch that we're going to talk about today, is transitioning from centralized water to on-site water, aka gray water system. That's a big part of it. That on-site reuse is a better strategy for developing our future water infrastructure than, as I mentioned, this energy intensive centralized municipal water treatment that we've relied on for too long. So let's pick up where we left off last episode and talk through some basic water saving techniques to make our home or building more sustainable than our neighbors, because that's what it's all about, right? Keeping up with the Joneses. Can
Get
you
them on
tell?
board too, though.
Well, yeah, but you do that by being the one who is willing to
The
go a
leader
little
in the
further,
field,
right? Yeah,
yes,
exactly.
absolutely.
The early adopter, as it were. Um,
Hmm.
Ginger, can you tell our listeners the three biggest water draws for the average American home?
Well, water usage, the most intensive water intensive usage is showering,
Hmm.
flushing the toilet, and
Hmm.
watering the yard. Am I there?
You hit the nail right on the head. Obviously, different climates have different needs when it comes to watering, overall water use, but across the board, those tend to be the top three in most climate zones. Can you potentially suggest a simple solution for how to reduce water use for all three? Is that even possible? A one and done?
It absolutely is possible. So, by using low flow fixtures for your shower head, toilet, and garden hose, you can actually make a huge difference for your home or building. And US collectively could save billions of gallons of water per year if massively adopted.
Hmm,
So, just despite the EPA advocating for water conservation, federal low flow flow rate regulations are not even close to what's out there product wise.
right.
So the state of California, for instance, requires all shower heads to be less than 1.8 gallons per minute, and the standard flow rate is 2.5, so it's not much less. That's a difference of 7 gallons of water for a 10-minute shower. However, multiply that by 30 for a multi-family property, and you're talking about 200 gallons a day savings. So that's pretty revealing. So to be sure to check out your fixtures for the lowest flow rate possible.
Um, wow. I mean, believe it or not, 200 gallons of water is only half of the high end estimate of what the average American family uses on a daily basis. That is shocking.
Mm-hmm.
So what can we do? We're a solutions-based company here. These low flow fixtures are all available at different price points, and you can actually find a complete list on the WaterSense website that I mentioned earlier. Similar to the Department of Energy's Energy Star program, which I think more people are probably familiar with, and we'll discuss more in our energy episode upcoming. The WaterSense Partner and Certification Program, it helps standardize these high-performing products so that when you see that WaterSense label, you know that it's a quality product that's ultimately going to help you save water.
We'll put the link in the show notes so you can check it out for your next project. And any homeowner can make an easy switch to start saving this essential natural resource right away. We don't have to think about it very often, but water is considered the bloodstream of our planet. So
I
we
like
got to
that.
keep it clean and keep it flowing.
Exactly.
So once we work with our designers to make sure we have water saving fixtures and appliances inside and the drought tolerant plants outside, what's next, Ian?
Good question. So while there are low flow options for sprinklers and garden hoses on that list that I talked about, you can actually take it to the next level by installing an ultra efficient drip irrigation system, which I touched on. You remember back in the day, Ginger, when you just bought a hose and just put holes in it? There was a name for it. I can't think of what it was called exactly.
I actually did that in my garden. That's called a soaker
A
hose.
soaker hose. Okay.
Rather than wasting 5 or 6 gallons of water every time you turn on a traditional garden hose or sprayer
Right.
on and off, you can use the soaker hose to find, and all you need to do is find someone to design a drip irrigation system to water your garden and outdoor landscape. So any landscape architects, if you're starting with a new build or a reno, worth of salt should recommend this from the very start
Mhm.
of the project. And a good sustainability consultant, such as ourselves, will know that this is a thoughtful design element and can make a huge impact on limiting overall water usage.
Yeah.
So
You got to
another
do it
small,
early, though, right? You got to get everybody
early
involved
on in
early.
the process, you
Yeah.
got to kind of have that plan going. So
Exactly.
another small change anyone can easily make is watering in the morning and at night. And so the water doesn't evaporate into thin air when it's hotter during the day. And that makes the water able to soak into the soil instead of be evaporated, like I said. and you can eliminate excess watering that way as well.
That's great. That's a great strategy. Doesn't cost you anything. In fact, can save you money. And it's a really fantastic segue into automation as well. Timed hoses, timed sprinkler systems have been around for a while. But you sort of take these ideas and add them together, and then you have a real winner. So imagine this. I'm going to paint a picture here. A centralized automated drip system that can be easily adjusted for different times of the year, or even better, one that monitors the moisture of the soil and can adjust on a day-to-day basis and seasonally for variable weather conditions. That sounds pretty far out there, right? I bet that really gets you going, Ginger.
That's very possible, though. Very possible.
We're only a couple hinges shy of a robot gardener there. You know, they need a Roomba for the outside.
If only, that'd be great, actually. But I like where you're going with this. You mentioned stormwater runoff earlier, and I wanted to expand on that a bit and talk about how important it is to account for rainwater in our design. And there, again, early on in the process, to come up with a rainwater plan. So what happens when it rains a lot in California is the first flush of rainfall never really percolates down into the soil. So even with permeable hardscape and a well-designed landscape, much of the water from a big storm simply washes all the environmental pollutants from months of sitting there on the hardscapes of no rain into the gutters and into the ocean. And we all know we don't want to pollute the ocean at all. So it's a huge problem for many local governments. So, what do you say is a solution for individual home or building owners and designers to avoid stormwater runoff when planning a new water system?
Well, step one is to capture as much of it as we can and store it. And then step two is keeping it clean. So you can do all of that with an old-fashioned rainwater collection barrel that you can get at your local hardware store. But that doesn't hold much water, pun intended.
As it were.
Yeah, exactly. A better, though slightly more expensive option would be some sort of underground or rooftop collection system that can hold more volume. Those systems often come with integration pieces to keep the water clean already. And then they can be gravity fed or pumped back into the irrigation system. And then this is where we get to that, big potable water savings, because you're using recycled water for watering instead of relying on potable water. And we've all seen, I think it's interesting, when you're walking around maybe commercial buildings or office parks or things like that, or city municipal parks, you can see they've got the little sign that says, all this water is recycled. So like, don't bathe in it or, drink it or anything like that.
Yeah.
So they've been doing this on the municipal level and some of these bigger buildings. They've been doing this for a long time. And finally it's trickling down, I guess, to another water pun, trickling down to, to like single family and smaller and smaller multifamily projects. So it's great, water savings everywhere. We kind of already talked about how our fresh water and therefore our potable water supply is dwindling due to climate change and population growth. So what's the reason that we can't just trust our city officials to deal with this problem on the city level? I mean, they've got it, right? They got to keep the water clean and treated and, pump it around and get it to everybody, right?
Well, I've spoken with some higher ups at our local utility companies, and the issue is the huge amount of energy and infrastructure required to pump all that water back and forth from a central location.
Yes.
And of course, here in California, drought is a big issue. So storing and cleaning water on site is just so much less energy intensive, infrastructure intensive, as none basically. So it's easier to automate, make adjustments when you meter and monitor everything on site. You really have a lot of control.
Cool.
So let's go ahead and transition to gray water systems. This is really the future of on-site water management. Can you explain to our listeners what gray water is?
Yes. To be clear, so we've transitioned, we're talking about wastewater now rather than storm or rainwater, slightly different. And if we design this system correctly, we can actually integrate both the gray water and the rainwater together for maximum efficiency, which is very, very exciting.
Very.
Yeah, gray water is defined as the wastewater from kitchens, sinks, laundry, various bathroom activities, obviously not including toilet water. That's called black water. We'll just forget about that term for now, but uh, worth mentioning. And within the last 5 years or so, many municipalities, including ours here in Santa Monica, have gone from seeing gray water systems as a potential health liability to actually recommending them in most buildings, as I was talking about, that sort of trickle down from the larger buildings. Ginger, can you talk about designing a gray water system for your single family home and the challenges that you ran into during that process?
Yeah, sure. We were very much on the leading edge of all of this gray water and recycling and reusing on site. So we consulted with a landscape architect to design a gray water system here in Santa Monica way back in 2015.
Hmm.
Seems like the dark ages in that
Yeah.
way.
Half a decade ago.
Way far away. As you mentioned, it was no easy sell at the city level because the idea was new. It was kind of newly emerging.
Mm-hmm.
In fact, the city of Santa Monica plumbing permit specialists advised me not to do it at all, just because it would be so difficult to get it through the process. So,
Wow.
but fortunately, municipalities have changed their tune. Things are really emerging. So now the city has instituted gray water design into their own buildings and recommended homeowners and developers to do the same due to state mandates and water reduction goals. So the times, they truly are changing and we're trying to keep up.
That's right. That was my Bob Dylan impression.
I know.
For anybody that doesn't know who Bob Dylan is or recognize that line. Yeah, I mean, they are changing. This is a huge shift in water management. It gives us so many more opportunities to limit our water use because we can use properly stored, properly sanitized gray water to not only water the outdoor areas, but, and this is that integration piece, also flush toilets.
Mm-hmm.
In most cases, if you're adding that in there, gray water system that can flush toilets, and you can use that in your rainwater for the outdoors, then for sure you're reducing your potable water use by at least 50%, if not more.
That's huge reduction right there. So,
Mm-hmm.
but what about the higher costs for all the materials, the automation tech, and the design itself?
Okay, cool. Good question. I mean, here's where we really get a chance to look into the future, because right now water bills aren't that expensive, right? But as water continues to become more and more valuable due to dwindling supply, then the amount of money saved over the life of a system like this would far outweigh any upfront cost. It's always, for the early adopters, it's always going to be a slightly higher cost. But as we talked about in our integrative design episode, our site analysis episode early on in the season, if you bring all this stuff, we keep hammering this, but it's the truth. If you bring it all together at the beginning, as early on in the process, then you have these opportunities to integrate systems, to think about ideas. You have more time to think about clever ideas because you've actually thought out some of the problems before and some of the solutions before you even get to them. And just remember that concept too of triple bottom line accounting. We've talked about it before. We're not just interested in the money side. We are also taking into account the human costs and the environmental costs in all of this. And you extrapolate that out over the life of a building that's going to be around 50, 80, 100 years or more. So being able to self-manage that water and kind of take charge of the quality of our water is important too. Very important, even more so in the future.
Absolutely. Ecologically, reusing water on site means our water supply will remain consistent despite any continuing climate change impact, which makes the property flood and drought resilient in a lot of ways. And so you mentioned foam flush toilets last episode. Did you want to talk a little bit more about that? That seems to be one of your favorite subjects.
Foam flush toilets, yes. Top 5, at least. When it comes to cutting edge technology and systems, I have 2 relatively new ideas I want to touch on. The foam flush toilets are the first one. But both are more applicable to, just want to make the definition that both of these are more applicable to larger commercial residential buildings like the one that we're actually designing here in Santa Monica. But as that technology continues to improve, I guarantee that we will start to see both of these in single family homes as well. Foam flush or composting toilets have taken a process that usually requires upwards of a gallon of water per flush. I think the low flow
The flow is
rate
1.8, right?
1.8, that's the regulation. But there are products out
Uh,
there that are like in the 1.2 to 1.3 range. But even then, I mean, and
Even
that's
then.
half of 2.5, which is the average going rate of a non standard toilet. So we're already, by instituting the low flow, we're cutting that in half pretty much. And then on top of that, there's this other option, and this gets it down to 3 tablespoons or 3
Uh,
ounces of water per flush. That's
That
almost
doesn't even
nothing.
seem possible,
You're
but
right.
it
I mean,
is.
even when you look at it, it doesn't seem possible, but it is. Yeah.
But it is.
And the only real requirement, other than designing the system, is you do have to rake and treat the compost a couple times a month. So
Yeah. Well, the biggest hurdle is getting people over that initial kind of disgusting thought about the human waste becoming compost. I
yeah, a
know it
little
did.
weird.
I had to do it myself, but not sure I'm totally bought into it yet. But I definitely I'm on the track. So I like the sustainability of it is being adopted more and more.
Yeah,
Even here in the city of Santa Monica, instituting their public buildings.
that's right.
So what's the second idea, Ian?
Yes, thank you for reminding me. The second technology is one that's been used in other countries for a while now, but Canada included. But due to, I think, presumed cost and some restrictive regulations like the gray water issue you ran into, the company is still looking for some open-minded folks here in the US to install this system as a pilot. It's a thermal recovery gray water system. And I'll explain what that is. It
Okay.
takes everything that we've been talking about and it amps it up even more by capturing energy from the transfer of heat. So you have shower water, right? Maybe it's 70 degrees or something like that, your shower water. And you're taking your shower, your normal water that's just kind of hanging around in your system is, 50 degrees or something like that. The delta, the change, that 20-degree difference, you can capture that energy the same way that you can cool air through an AC unit. It has a coil in it, and you're basically just transferring heat energy through that coil. And so by doing that, you can use that energy, that heat, to heat other spaces in the building, literally bringing down energy loads from one of the highest energy consumers in a building, which is your HVAC system. That was a lot of information. Like we said, we'll go into
Mm-hmm.
like a little more detail about how it all works at some point, but and we'll definitely be talking about other ways to lower your energy consumption in our next episode devoted entirely to energy. So this is a really nice transition, but just imagine how efficient your building or your home could be if you had a solar powered system. So now your energy is actually coming from the sun, uh, which is renewable, fantastic, and that would capture your thermal energy. So you're not only getting to use your water twice, you're getting to create energy from your water and then use that in the form of energy to power other parts of the building. I mean, this is like
Yeah, that's
capturing thermal energy, you're capturing from your wastewater, you're lowering your water use from anywhere 50 to 80%. I'll go out on a limb and say if it's a solar powered system, I mean, you might even be eliminating the majority of your water use. That's not for drinking or cooking, really,
hmm, hmm.
which is great, because if we only have 1% potable water, I'm just kind of thinking about this right now, but
On
if
the
we only have one
planet.
on the
Yeah.
planet, then maybe 1% of our water use should be fresh water. That would be pretty cool. We could move
Wow.
toward that.
That's
There's
very
You mentioned that
21st
program.
century.
Yeah. I mean, and you mentioned that program too, the net zero water, which is
Yeah.
really
For the
cool. We're going to
energy.
talk more about that, but there's a
Delta.
net zero energy and then there's a net zero
Mm-hmm.
water. There's the answer right there.
Mm-hmm.
Slam
Mm-hmm.
dunk for LEED Platinum. Very cool.
Very cool. Very cool indeed. So 21st century.
Yeah.
So listeners, if you're interested in learning more, you can email us directly at info@shfbuild.com, and Ian will gladly put you in touch with the founder of the company. And that's about it for today. As always, we encourage you to reach out with questions, suggestions, new topics, and new guests. We love it all.
And please tell your friends about our podcast, share the link, contribute, just listen, whatever you feel inclined to do. Thank you, Ginger. We're just so happy to have you all here.
Mhm.
Happy to have my co-host here as well. We covered a lot today. That was fun.
We sure did. So, hope it was some value to you, our listeners. Email us your thoughts and questions. We look forward to the dialogue. Absolutely. So, thank you, Ian.
Yes. Thank you, fellow green building enthusiasts, for listening to the Building the Future podcast. Until next time, make sure to think about water in your overall design. Whether you're in a drought zone or not, it's important to make sure that our water infrastructure is designed to overcome current challenges and climate change. Building the Future, Green Building in the New Millennium, brought to you by Sustainable Homes of the Future.